Today we're going to be using a Raspberry Pi and an old RC car to build something really cool. Hey guys, I hope you are doing great. Most of you know that I'm really into Raspberry Pis. If not, you should go watch some of my other videos because I have quite a few videos about them. By the way, let me know if you want more. I really enjoy using these Raspberry Pis, and there's been one project that I haven't done yet that I really wanted to do. That's to build essentially a remote control vehicle that can be controlled by a Raspberry Pi that's on the actual machine itself, and then you can remote a desktop into the Raspberry Pi to control it from your laptop anywhere that you have internet from, well, as long as you're on the same network. So I'd also like to put a camera on it, so essentially at the end of the day you have a machine that you can drive around from your laptop, see exactly what it sees, and you guys are on the same Wi-Fi network, and that's how you're communicating with it. So I wanted to do that, and it's definitely not an original idea. I mean, people have done that lots of times before, so that's not new at all. But I just have never done it, and I thought it'd be fun. So today, that's what we're going to do. It's probably going to be over a couple different parts because I don't exactly have everything I need to build the robot right now, but I have, at least for the main chassis, I have the material, so I figured we'd go ahead and start today, and then finish it off in a later video. Let me go ahead and go over the components that I have right now, and how we're going to compile them to make this. First, I have this old gearbox and chassis from an old broken remote control car, but the motors are still in perfect condition, so I figured why not use them. They seem to have very good torque. They can run off. I'll probably be using a pack of AA's to run this as power. I don't know yet, but they don't take much and they seem to be pretty quick, so I figured why not use them. I've actually glued a Lego plate on top of this, and that's so we can actually 3D print components to attach to the Lego plate, and I can just take my calipers and 3D print something to attach onto the Lego studs to hold our components. Next, of course, is a Raspberry Pi. I'm going to be using a Raspberry Pi 3 wireless in this case. I guess all the 3s are wireless, actually. Third component we're going to need is this little L298N motor control bridge. This is very important because the Pi cannot produce enough power to run the motors on its own, so this little thing will basically act as a switch between the motors and our external power source. And then, of course, a bunch of wires and probably other switches that I'll add later on. Alright, let's go ahead and go down to the shop and I'll start wiring all this up. Okay guys, I am now down in the shop, got all my components laid out here in tools. Let's just go ahead and start wiring things up. I'm going to move the camera so you can actually see what I'm doing. As far as how I'm wiring this, I'm using a very common wiring diagram. It's by Explaining Computers. So if you guys want to check that out, link is in the description. I'm not really going to talk about how it works because it's if you really want to know, you can just go search it out there. Basically, we have to hook the GPIO out pins of our Raspberry Pi into the input pins of our board, the output pins of our board, to the motor, and our power supply, probably going to be these batteries here, move my camera, to the power input of the bridge, and then of course we have to power the Pi via the micro USB cable. But that's not wiring, that's just common sense. Now eventually I'll be going to 3D printing some mounts to so we can attach all of our components to the Lego board like I said, but for right now I'll just grab some sticky tack just to hold things on there for the moment. Alright, now that our components are mounted on there, I'm going to go ahead and start wiring up. First off, we have to wire each of our motors to the corresponding ins and outs. This is our right motor. We'll have the right motor. Let me show you how this works here. So on this board we have two motor outputs, one there and one there. We're going to have the motor 1, or what I'm going to designate as the right motor, to be out 1 and 2, and out 3 and 4 to be the left motor, which I'll be calling motor 2. You'll see that again in the code. Alright, as you can see here, I have both of my motors now wired up, and I'm going to start connecting the GPIO pins to the board using this wiring diagram. I'm going to be using pins 7, 9, 11, 13, and 15. 11, 13, 15, and 7 are my GPIO pins, and 9 is my ground. I'll mostly just be using some of these jumper cables here as well as this. Actually, I believe this is for a stepper motor off of a 3D printer, and this has the same type of connection to the board, so I'll probably be using that as well. That's just a 4-pin bundle. Just for this initial wire up, I'm going to be using a 9-volt battery to power this thing, but don't worry, I'll eventually be getting a 4 AA's to power it probably. I just don't currently have a battery pack to put these 4 AA's in. So for today we'll just be using this 9-volt, but I'll definitely switch that out later because that 9-volt will not last very long at all. Well, I'm further along the wiring now. I'm just soldering together a couple wires here. I do not have any female to female jumper wires, so I'm having to make my own here. I really need to order like a pack of jumper wires. Jumper wires are the most useful thing to have when you're building, you know, physical electronics with the Raspberry Pi, simply because it's so useful, especially if you have a breadboard. Use lots of jumper cables, don't even need to solder anything, but I think this will work just fine for this project though. I need to twist some more wires together actually. Alright, so I've got the bulk of the wiring finished. Let me go ahead and sort of show you what I'm talking about here. I'm using GPIO pin 7 for N1, 11 for N2, 13 for N3, and 15 for N4 on the L298N. That is, of course, the board layout of the GPIO numbers. If you have no idea what I'm talking about, that's okay. Just research Raspberry Pi GPIO pins. It'll tell you all about it. I haven't fully hooked up the battery to the L298N yet. I was going to insert a switch, but I figured I'll wait till I have the actual battery pack to do that. So I'll just plug it in whenever we're ready. Now we just have to do a little bit of programming, so let me go ahead and grab my laptop and show you how all that works.
Alright, so we are now here at the computer to go ahead and talk about some of the code I've installed on the Pi to actually run the robot. As you can see, I have VNC Viewer up here. I've installed Tight VNC on the Raspberry Pi so I can remote desktop into it. Every time I turn on the Pi, it automatically connects to my network. I can simply log into the IP address, type in a password, and I now have access into my Pi completely wirelessly. I've created a directory called PiBot in my home directory, and I have 2 files, bot control, which is the main control file, and then curses test. Curses test is just a file I created sort of show you guys how this all works. Let's go ahead and open up that file first. By the way, all of these codes I'm writing in Python, if you didn't figure that out already. It's a really simple language, easy to work with, and it does pretty much what I need. But you could also easily code this in C#. I'm not so sure about Java, but probably C#. Java's implementation of hardware and software, especially with the Raspberry Pi, is a little weak. But again, if you guys have figured out how to do this in Java, I would, greatly like to know that. Please leave that down in the comments because I would love to know how to do this in Java because I enjoy coding Java much more than Python. Anyway, though, let me go ahead and talk about what we're doing here. We're going to I won't go into too much detail about this. Don't worry, I'll make this as quick as possible. But if you guys want a more in-depth tutorial on how to code this, I have a link in the description of the tutorial that I followed. I did edit it a bit, but it's pretty much that. And so if you're actually making this, go check him out. He's really cool. But first, let me just go ahead and we import some libraries, set up the libraries, and basically I wrote this little bit of code here, which will ask for all of my keystrokes, and if they are certain letters, they will do certain things. As you can see here, if you guys know anything about code, I just have a bunch of if statements here. For instance, if I press, in this particular piece of code, if I press the W key on my keyboard, it will just print out W. Let me go ahead and run this piece of code and show you what that looks like. Also, because I am using curses, that will not work in idle, so you're going to have to run these from your terminal. Alright, so now the program is running, and as you can see here, it has given us a blank screen and turn off echo. But as you can see here, if we hit W, it actually just prints out the W key, prints out the A, prints out the S, prints out the D. Now if I hit any other keys, they don't really do anything except for the space key. It also can recognize the space key as well as Q to quit the program. This might seem very arbitrary, but when we combine those ideas with GPIO output controls, we can have a pretty cool little program. So basically what that piece of code did is it collects the data from my keyboard and applies a command to each key. In the actual piece of code I'll be using to run the robot, it's pretty much the same thing, only I've also imported some extra libraries to run the GPIO pins, and then what I've done is in the commands that it runs, it still collects every key that I showed you, but instead of obviously printing it out, it just sends a set of commands to the GPIO pins, which tell the motors to either go left, right, forward, backward, and so forth. When I run this piece of code, the WASD keys don't seem to do anything, but of course if I had my Pi hooked up to my motors, W would make both motors go forward, S would make both motors go back, A would make the robot turn to the left, D will make it turn to the right, and space will make it stop. This will all be much more apparent once I actually show you the Pi as I'm doing this, and then of course to quit the program we just hit the Q key. That's pretty much all I need to show you guys here. If you guys really want an in-depth tutorial on this, again, just go to the link in the description. Very simple tutorial. It's really not that hard to code. It's really short and easy to set up. That's all I'm going to talk about here. Let's go ahead and go to the actual Pi and show you some of our hardware while it's working.
So after I wrote that code, there was really nothing left to do but to plug a 9-volt battery into it and see if the code worked. And it worked okay, but I wanted more. So then I decided to get a 3-cell LiPo battery I usually use to fly or see planes. This is 11.1 volts, but it can supply a whole lot of amps. So I put that on it, and it worked really well. Really well, meaning that it was completely overpowered and impossible to control. So then I decided to go ahead and rewrite my code and use the PWM features, that's pulse width modulation features of the Raspberry Pi, to actually control how much current was going to the motor so I can control the speed. As you can see, the code was pretty much the same. All I did was import some more libraries, and then of course PWM is not a on or off, it's a percentage of how much current is going to the motors, so I adjusted that accordingly, and it seems to work just fine. Let me go ahead and show you what I've done so far. Well, here's the main bot here. As you can see, it looks pretty much identical, although I have added this clear case here and ordered a power supply for my Raspberry Pi that slips in right here just like that. Of course, I have to have the right part of the cord plugged in to provide power, but that slides in just like that and connects to the Pi here. This way we can have power to Pi independent of a wall outlet. Why is that cord moving by itself? That is creepy. As for the lithium polymer battery, I just have a bit of sticky tack holding this down here, and of course I have soldered on an XT60 connector to my main board, to which I can plug in power like so. That works pretty well. Now, of course, I will definitely be 3D printing, or at least making an enclosure for this bot to cover up all the wires and parts of this to make it much cleaner and better. And that's going to be in part 2, like I said at the beginning. Let me go ahead and show you what this thing can do right now. Well, I have now booted up the Pi, and as you can see, it automatically connects to my network, and I can remote desktop into it, as I've already shown. Now I'm just going to pull up the terminal, go into the directory, run that file, and of course connect my battery to the control board. And I can use the WASD keys, and of course the space key, to start and stop the movement. Also, with the PWM setup in the Python code, I can also change the speed at which it moves, and I've already calibrated and trimmed it correctly. I believe one of the bearings on the right side are a bit tighter than the left side, so I actually had to trim to account for that, but it seems to be working quite well this time. I haven't yet gotten a full battery test to see how long it will actually last, but I ran it for at least 10 minutes, and it hardly used the battery whatsoever, so it does seem like it has a pretty good lifetime. Of course, those motors are hardly drawing any amperage at all, so that would be expected. So as you can see here, when I press the W key on the keyboard, and then I hit the space to stop it, in the current Curses library setup that I'm using to log the keystrokes, it cannot detect when the key is depressed, so unfortunately I have to use the space to stop it, but that seems to be working quite fine. I haven't had any problems with it as of yet. This is too much fun. And the cool thing about this is that the range of this thing is incredible, because instead of having to create its own network and be joined to that, like I said, I'm using my home network, which has great range, and not only that, but it's actually doubled the diameter of the range of that, because just my computer has to be in range of the network, and the bot has to be in range, so we could both be on the completely other spectrums of the circle of range, whereas if I was to connect directly to that, I would only have so many feet in line of sight of it. So this is a really good setup, and will work really good once I have a camera on it. Well, I think that about does it for part 1 of this project. Part 2, I'll be 3D printing, or if I can't 3D print, I'll at least make an enclosure to cover up the electronics, as well as adding one of these little board cameras that the Raspberry Pi Foundation supplies for their boards. And I'll definitely be taking use of that, and hopefully get a pretty good stream off of the machine. Look forward to that coming up next. I'm Josiah, thanks for watching. You like that?